Hello, my name is Felipe Gavilan, and in this video, we are going to see an introduction to asynchronous programming in C#. We'll see what it is, when we should use it, and we will learn how to write an application that downloads several files at the same time in an efficient way. So, let's get started. To start, a little definition. A thread is a sequence of instructions that can be executed independently of other code. Asynchronous programming allows us to use threads efficiently. By using promises and callbacks, threads are prevented from being unnecessarily blocked. Let's look at an analogy. Suppose you order a pizza through your phone to have it delivered to your home. They tell you it will take 30 minutes. What do you do in those 30 minutes? Do you freeze right there, waiting for the pizza? Or do you do other chores around the house while the pizza arrives? You obviously want to make the most out of your time, so you decide to do a few things while you wait for the pizza. Common sense. In our analogy, the preparation of the pizza is an operation which is not going to be fulfilled immediately, and you are like a thread. Instead of being stuck waiting for the result of the operation, it is better to do other things. Asynchronous programming allows us to manage the threads of our processes in a more efficient way. The idea is to avoid blocking a thread waiting for a response from an external system, such as a web service or a computer's file management system. This optimal thread management provides us with two very important features: vertical scalability and a user interface that does not freeze. Vertical scalability refers to an improvement in the processing capacity of our application. There are several ways to achieve this scalability, one of which is by using asynchronous programming. For example, if we have a web application, it will be able to serve a larger number of HTTP requests at the same time by using asynchronous programming. Each HTTP request is handled by a thread, and if we avoid blocking threads, then there will be more threads available to process HTTP requests. When we talk about a user interface that does not freeze, we're referring mainly to desktop and mobile applications, which the user will be able to continue interacting with even when there is a process in progress. The interaction with the user interface is handled through the UI thread. So if you allow the UI thread to hang waiting for a long task to be done, then the user will not be able to interact with the application. Using asynchronous programming, we can avoid blocking the UI thread. To work with asynchronous programming in C#, we use async await. The idea is that we can use async to mark a method as asynchronous. And with await, we can wait for an asynchronous operation so that the original thread doesn't get blocked. Typically, methods marked with async return a task or task of t. The idea of task is that it represents an asynchronous operation. In the case of task of t, it is like a promise that in the future, this method will return a value whose data type is t. Asynchronous programming can be used in any environment, both desktop, mobile, web, and so on. The normal thing is to use asynchronous programming when we're going to communicate with external systems. For example, if we have to communicate with a web service from our application, we will want to use asynchronous programming. This is an I/O operation. I/O, which stands for input-output, are operations characterized by the fact that their realization depends on communication between systems. This is why asynchronous programming does not improve the speed of the processes, since there is no way that we can make the processing speed of an external system faster from our system. The most we can do is be efficient in managing our threads so that we don't waste resources waiting for I/O operations. Let's see the importance of using asynchronous programming with a simple example. We will see what happens if we perform an operation that takes several seconds. The first thing that we need is an application, so let's go to Visual Studio. Alright, so for this tutorial we're going to use a WinForms application, though whatever we learn here will work on ASP.NET Core, that is web applications, mobile applications, and so on. So let's create a new project. I'll write here WinForms. I'll choose this one, not this one, the one that says .NET Framework, but this one. So click on Next. I'll call it Async Intro Demo ENG. Next, .NET 7 and create. Alright, so here we are. Let me press Ctrl F5 just to see that everything works. And we have here our application. So the first thing we need is to add some controls into this UI. So for that, we're going to go to Toolbox, and if you don't have Toolbox here, you can always find it in View Toolbox. Let's go to All Windows Forms, and I need to have a button. Let me drag a button here on the screen, and also a picture box. So let me go back to Toolbox. Let's look for picture box, and let me drag this here. So we're going to have a picture, which is going to be a loading GIF, and also a button, which is going to fire up a process. So let me press F4 after I click on this button, and let me change this text to begin, and then let me put this here and this here. Now I need that loading GIF that I want to put here. For that, we can go to Google, I'll write loading GIF and go to Images. I'll choose the one that says Wikimedia Commons, click on here, right click on here, save image as, and I'm here in my project, so let me just say loading, enter. Now let's go back to Visual Studio, click on here, choose image, local resource, import, loading GIF, open, OK, size mode, center image, and now let me just make this a little bit bigger so that we have here our loading GIF. Here is just fine. Let me press Ctrl F5 one more time just so that you can see the UI of our application. As you can see, we have the loading GIF and the button. The idea is that when we click on the button, we're going to display this loading GIF so that the user knows that they have to wait for some processing to be done. Now, of course, we don't want this loading GIF to be immediately displayed when we open the application. So what we're going to do is that we're going to come back here, click on here, F4, and then let me go to Visible and make it false by default so that we hide this by default. Alright, so now what we're going to do is that we're going to double click on this button so that we can create an event that is going to execute this function when we click on the button. So let me just make a simple text, message box.show you have clicked the button, semicolon here, Ctrl F5 to run our application. And now let's see that if I click on begin, you can see that I have this message box here on my screen. So let me close this. And now let's do the following. What I want to do is that when I click on the button, as I mentioned before, I want to display the loading GIF. So please notice that this control that we have here, this picture box, has a name. If we come here, we can see that we have name around here. Here we have name, picture box 1. Alright, so that is the name of this control. So what I'm going to do is that I will come here and I will say picture box 1.visible equal to true. So when we click on the button, we're going to display the picture box. And after we finish the processing here, we have some slow processing. We want to hide again the picture box. Alright, that makes sense. So what kind of a slow process are we going to do? Well, just to keep things simple, I want to do the following. I want to say thread sleep 5 seconds, 5000 milliseconds, or 5 seconds. Now, let's see what happens when we freeze our thread, the thread that we're using, the UI thread. Ctrl F5 to run our application. Let's come here and let's click on begin. And just before I click on begin, notice that if I put my cursor here, you can see that this X gets colored in red, right? Alright, so let me click on begin and let's come back here. And as you can see, this is not turning red anymore. And not only that, but if I click on begin one more time, because 5 seconds has already passed, if I click on begin one more time, I can't even drag this window. Why is that? Well, the reason for that is that the UI has frozen. And the UI has frozen because we put the thread to sleep, and that means that the UI thread will be blocked, and therefore we cannot interact anymore with our application until 5 seconds passes, and then that thread gets unblocked. So that is a problem. That is a bad user experience. So why is this happening? Well, this is happening because this is a synchronous method. This is a synchronous method. If we're going to make a long processing operation, we should use asynchronous programming so that we can liberate the thread that is executing this code. So how do we use asynchronous programming? Well, remember that just a few minutes ago we said that we need to mark this method as async, and then we have to use the await operator. So let me comment this out because I cannot use the await operator on this method because it is not asynchronous. We can only use the await operator on asynchronous methods. So let me say await task delay 5000 milliseconds. That is basically the same as thread sleep, but this one is asynchronous. So let me write here asynchronous. Alright, so let's see what happens if we execute our code now. Ctrl F5, let's drag this over here, and let's see that if I click on begin, we're going to see that we have this loading GIF here, and we can also interact with the window. I can click here again, and we can see that I can interact completely with this window without any issues. Now, you may be wondering, just a minute ago, when I click on begin, I wasn't able to interact with the application, but also the image didn't appear, right? You remember that? That is because, as we said, the UI thread was blocked and therefore our application was non-responsive. And that means that we weren't able to make any updates to the UI, and that includes displaying the loading GIF. It is extremely important to reiterate that the await allows us to perform an asynchronous wait. That is, when we do the await, the rest of the method is not executed until this operation is finished. However, the execution thread is released so that it can be used in other things. That is what makes the UI usable, because when we invoke the click event, we do it with the UI thread. The UI thread is the thread that handles changes to the user interface. By doing an await, we allow said thread to be released after 5 seconds has passed, that is, after this method finishes. The difference between this version and this version is that this one blocks the UI thread and this one doesn't. If we want to, we can put a message box here so that you can see that after 5 seconds, we get the message box on the screen. So let me press Ctrl F5. We have to close the application. Always remember to close the application. Ctrl F5 one more time. And now let's come here and let's say begin 1, 2, 3, 4, and 5. And as you can see, we have hello Felipe. That is great. Now let's come here and let's wonder what makes this method asynchronous. Well, if we see the data type that this method returns, it is task. If we see what sleep returns, it is void. So as you can see, there is an important difference. One is a void method and the other one returns a task. Remember that we said at the beginning of this tutorial that task basically represents a promise that an operation will finish in the future. It will not necessarily finish immediately, but it will finish in the future. Task basically represents an asynchronous operation. So if we have a method whose returns type is task, then we know that we are in front of an asynchronous method. Let's see something. Let me remove this synchronous method from here. I don't need it anymore. But what I want to do is to put this in another method. So let's come here. Let me say private. Since it is an asynchronous method, I need to mark it with async. So async. Since again it is an asynchronous method, I want to return task from it so that we know that it is an asynchronous method. Now let me say long processing and let me put this here. Now just to be faster, I'll just make it 3 seconds. Now let me remove this from here because I don't need it anymore. And finally, let me invoke this method from here. I will say await long processing. Now notice something. Notice since this method returns task, I can use await. But if I put here a void, for example, if I put here a void, you can see that we cannot use await anymore because await works on task, not on void. So let me say here task again, and we're not going to have an error here anymore. So notice something. Notice that here in long processing, we have this method that is asynchronous, which returns a task. I mean the delay method, and we use await there. But also here in button one click, we have this method that is also asynchronous because it returns a task. We also use await here. So as you can see, we have to use await all the way down. We have to use await here, and inside of this is this where a method that comes from us, we will have to use await inside of it also. So just keep in mind that you always have to use await. Now let's see that this works. Control F5. We have to wait 3 seconds. 1, 2, and 3. And this is good. Now what happens if we want to return a value from here? Well, in that case, let me clone this method. And I'll put it here, returns name. Let's say that this long processing returns a name. So instead of doing task, I want to use task of a string. I say a string because I want to return a name. If it were a number, it will be an integer. If it were a date, it will be datetime, and so on. So let me say here, return Felipe. So this method will return Felipe after 3 seconds. Alright, so I can come here and paste that here. And I can say var name equal to await long processing return name, and in here we have a string. It is really important for you to use await. Let's see an example. First, let me come here and let me say message box show string interpolation hello, and I'll put name here. You are going to see that this works. You are going to see that we get, after 3 seconds, we are going to get hello Felipe. As we can see here, we have hello Felipe. Great. But what if I forget to use await? Well, in that case, instead of having a string here, remember that when we have await here, the data type of name is a string. But if we forget to use await, now what we have here is task of a string, which is different. Now, if I press Ctrl F5, we're going to see 2 things. The first one is that we're immediately going to get this message box, and the second thing is that we don't get Felipe. We get system runtime, compiler services, and so on, because this is the 2-string representation of a task. But that is not what we wanted. What we wanted to have was the name, in my case Felipe. I didn't want to have this here. So when this happens, please make sure that you are using all of your awaits accordingly. And just to reiterate, notice that in here, since we want to return a value, we say task of a string. So this is an asynchronous method that returns a string. But here, since we don't want to return anything, we can just say task. So task is like a void, like a method that doesn't return anything, but that it is asynchronous. And here we have task of a string because we want to have an asynchronous method that returns a value. Now, it is time for us to address the elephant in the room. Why do we have here Async Void? We just said that when we want to have an asynchronous method that doesn't return anything, we say Async Task, but here we have Async Void. In general, Async Void is very bad, very dangerous. If you have, for example, Async Void in an ASP.NET Core application and you get an exception, you are going to break your whole application. That is, your application will totally stop working just by a single exception. That is how dangerous Async Void is. Now, that means that Async Void is an anti-pattern. It is an anti-pattern. The exception, because there is an exception, the exception is events. You can use Async Void when you have an event. This is a click event. So this is a method that responds to the click event. So in this case, it is allowed to use Async Void. It is fine in this case, but in general, you should avoid using Async Void. Again, this is the exception, so this is fine, but here you shouldn't use Async Void. You have to use Async Task. So far, we have been doing one asynchronous operation at a time. There are occasions where we want to perform a set of asynchronous tasks independently and wait for all of them to finish. For that, we can use task when all. Let's see an example. Let me create here an asynchronous method. So private async task. I don't want to return anything, so just task. Long process A, await, task delay. I want to wait 1 second. Console write line, process A completed. I'll say completed. Now I want to do the same for B and C. So B here, C here, and C here. Alright. So we have these 3 methods. Please notice that each of them takes 1 second to complete. Process A takes 1 second, process B takes 1 second, and process C takes 1 second. So, if you execute them sequentially, it is going to take 3 seconds to complete them, right? let's see that. Let's come here. Let me delete this and this from here. Since I want to measure time, I need to have a stopwatch. So I'm going to use a stopwatch. I want to start the stopwatch. After that, I will say await. Let me say await like this. Long process A. And then the same goes for process B and process C. And then I will say stop the timer. And then I want to write on the console the duration of these three methods. So let me put this here. The program executed in this amount of seconds. And then I write that on the console. Next thing I want to do before running the application is to come here, right click, properties. I want to convert this application into one that is going to display a console. So instead of output type Windows application, I want to have console application. And that's it. With this, I'm good to go. Control F5, and we're going to see that we have a console here, and also our application. And if I click on begin, we're going to see that we have process A, process B, process C, and the program executed in 3 seconds, which is great, which is what we were expecting. Now, sadly, this is not an efficient way of working. Let me close this. This is not an efficient way of doing things, because notice that these 3 methods are independent, and therefore it doesn't really make any sense for us to execute them sequentially. We could execute them at the same time, concurrently. And in that way, we're going to have our program execute faster. Let's see that. Let's see that instead of doing this, I can have, remember that this returns a task, right? A task is a data type. So we can make a list of that data type. So I can say tasks, new list of tasks, and then after that I will pass long process A, and notice that I'm not awaiting because I don't want to await here. I just want to have the tasks that each method return in this list. So long process C. Alright, semicolon here, and now here I want to use await task when all. This when all method will allow me to pass a collection of tasks, and then when all of the tasks finishes is that we're going to execute the following line of code. Let's see that. Control F5. Let's come here. Let's put this here and this here. Begin. And let's see that here we have process A, B, C completed in 1 second. Now this is great. This means that we were able to execute the 3 methods at the same time, which makes our program faster. Now, it was a coincidence that we have A, B, C here. If I click on begin one more time, we're going to see that now we have C, A, B. After that, if I execute it again, we have C, B, A. What I mean by this is that since we're executing the task concurrently, we don't have a guarantee of the order in which they're going to complete. They can be completed in any order. We can't control that. But in our case, that doesn't matter because they are 3 independent tasks. But maybe in your case, that does matter to you. So that would be one reason for not using task when all. But in our case, in which the 3 methods are independent, we can indeed use task when all. Alright, so let me close this and let's continue. Let's see a slightly more realistic example. We're going to download images from the internet simultaneously. In order to perform this task, we need the HTTP client. As its name indicates, the HTTP client allows us to make HTTP requests. Thus, we can communicate with web servers using the HTTP protocol. So what we're going to do is to go to Google. I'll go to Google and I'll look for my country, Dominican Republic, but I want to go to all. And I want to open the Wikipedia page, and I want to look for 3 images. This one, and this one are fine. Now, what I want to do is that I want to download these files, these images, several times. So what we're going to do is that we're going to come back here. I want to create a class. Let me create a class that will contain the name of the image and its URL. So custom image. And we're going to put here a string name. Let's forgive the null. And the same goes for the URL. After that, we're going to create a helper method here. We're going to say private static list custom image get images. And we're going to say for I'll say a 7 here because, as we mentioned, I want to download these images several times. I want to do it several times because we're going to test whether it is faster to download these images sequentially or concurrently. Now, of course, we need to have enough files so that we can see a difference between the two algorithms. So let me say here, I want to say here var images, new list of custom image. Then in the end, I want to return images, and then in here, I want to say images, add new custom image, and I want to say name. So the first one is going to be called Hispaniola. So Hispaniola here, and let me put here this, and then this, like this. This should be PNG, and then the URL. So let's look for the URL, right click on here, copy image address, paste that here, and we have the first image. Now we need the other two, so let me clone this twice. Now let's go for the second image. I'll call it Cuevas. Let me put this here. This is a JPEG, and now right click here, copy image address, and let me take this from here and put this here, the URL. Alright, that is fine. And the last one will be called Los Tres Ojos, which means the three eyes. This is a JPEG, so JPEG here, and then the URL, copy image address, and then let me put this here. Alright, so we have the three images here, and we're going to download them 7 times. Since we're going to run this test several times, I want to have a few helper methods. One of them is going to allow us to delete these images that we're going to download and store in our hard drive. So this method will allow us to delete all of the files in a directory. This other method will allow us to delete the files in 2 folders, the parallel folder and the sequential folder. And as you may imagine, in the parallel folder, we're going to put the images which we download using the parallel algorithm, and the same goes for sequential, but in this case the sequential algorithm. Now to download the images we need the HTTP client, so for me it suffices to put it here. And now let's create a method that will allow us to process the images. So private async task, it will be asynchronous, so async task. It will not return anything, so just task and not task of t. Process image, string directory, custom image, var response equal to await HTTP client. We're going to use the HTTP client. We're going to use getAsync. As you may notice, this getAsync returns a task of t, task of HTTP response message, which means that this is an asynchronous method, and therefore we have to use await. Now, of course, it is asynchronous because what we're doing with the HTTP client is to communicate with a web server, which is an I/O operation. So let me put here image URL var content equal to await response content read as byte array async. So we're getting the image and we're converting it to a byte array. Now we're going to use the bitmap data type so that we can easily transform our image and save it into our hard drive. So using var ms of memory stream, new memory stream, we're going to use a memory stream content, and then we're going to say bitmap equal to new bitmap ms semicolon, and then after that I'm going to transform the image just for fun. So rotate flip, and yes, I do rotate images just for fun. Rotate flip type, rotate 90 degrees, and flip none. Var destination equal to path combine directory and the image name. So image.name semicolon here, bitmap save and destination. Alright, so this is our algorithm. This is the one that will allow us to download the image, transform it, and then save it into our hard drive. Now again, what we're going to do is that we're going to have 2 algorithms, one that is going to download the images sequentially and another one that is going to download them simultaneously. So I need some preparation code. I need a few variables. So let me come here before the stopwatch and let me paste this So we have here the current directory, a sequential directory, and a parallel directory, and we have prepared execution, and we're passing parallel directory and sequential directory. After that, we're going to write begin on the console, and then I want to have the list of images. So we have get images here. Now let me do the sequential algorithm first. So we have our stopwatch, right? Let me remove this because this was from the previous example. Sequential part. Now sequentially what I will do is that I will process each image. So for each image in images, await, process, image, sequential destination, sequential directory, and the image. That's great. After that, I want to write on the console how much time it took to download each image sequentially. So let me say sequential duration in seconds and this. Alright. Now after that, I have to reset the stopwatch. So SW, reset, and then start again, start. And in here I will say parallel part. So instead of doing this, instead of doing a for each, I want to build an innumerable of tasks. So let me do the following. Let me say tasks equal to images. Remember that here we have a list of custom image, right? Now what I want to do is to map this list of custom image into a collection of tasks. Now, what link queue statement allows me to map or to project? Select. So let's do select here. So select async image, semicolon, await, process, image, and then directory, parallel directory, and the image, semicolon here. So with this, we are mapping images into a innumerable of tasks, as you can see here. Now after that, we know that we can do await task when all, and then tasks. And that's it. Now after that, I have to come here. Let me delete this because I don't need it anymore. What I will do is that I will copy this and paste it here, but I will say here parallel, the parallel version. And I believe that's it. With this, we're good to go. Let me press Ctrl F5 and we're going to see that indeed we can execute this code twice, one in a parallel version and the other one in a sequential version. Alright, so we click on begin, and as you can see, we have here sequential, duration in seconds, 2.7 seconds, and here we have parallel, duration in seconds, 1.2. That is less than half the time it took in the sequential version. So as you can see, not only were we able to download images in parallel, but we made it in a more efficient manner than our sequential algorithm. So as you can see, it is worth it to learn asynchronous programming in C#. Just so you can see it, let me come here and let me come to here so that you can see that we indeed downloaded the images. Let's come to Bing, debug, net7, images, and we have, for example, the images in parallel, and as you can see, we have the images flipped. If you want to learn more about C#, buy my Udemy course today. It is a course that goes from beginner to advanced concepts. I also have a course that goes deeper into asynchronous programming and parallel programming, and that is my Introduction to Concurrency in C# course. Link with a discount to all of my courses in the description of this video. Thank you.